The James Webb Telescope may have detected the biosignature of extraterrestrial life on K218b. Specifically, it found traces of the sulfur compound dimethyl sulfide, which is typically produced by organisms on our planet. But how did the experts manage to discover potential biomarkers in the exoplanet's atmosphere in the first place? Can we finally answer the oldest question of humanity, whether we are really alone in the universe, with a clear no? And above all, if there really are aliens out there, why aren't they here? The last question is truly not a new one. It describes the simple yet agonizing core of the Fermi paradox, which was put forward in 1950 by the physicist Enrico Fermi. It deals with the mysterious absence of our extraterrestrial neighbors. In principle, one might think that the universe has actually provided enough time and celestial bodies to allow the development of countless civilizations, and yet, there is still no trace of our cosmic contemporaries. Well, at least officially. Of course, as is well known, there are also countless clips circulating on the internet in which we see bizarre flying objects that are literally not of this world. Then there are the statements of men like David Grush or Bob Lazar, who claim that the US government has been running a secret UFO recovery project for decades. But before we delve too deeply into the field of controversial speculation, we should stick to the officially confirmed facts for now. Despite all the Voyager golden records and WOW signals, these still tell us that we Earthlings are the only known life forms in the cosmos. But isn't that strange, given the thousands and thousands of formations in the starry night sky? Is it even possible that the Earth is the only celestial body in the universe to have produced life? Well, quite a few researchers answer this with a definite no, including Tom Westby and Christopher Consolis from the University of Nottingham, who, as part of an astrophysics study, came to the conclusion that 36 highly developed civilizations could be slumbering in the Milky Way alone. The two scientists explained that the fact they have not yet attracted attention is due to the gigantic distances that prevail between the individual alien peoples. After all, this averages around 177,000 light-years. And just to clarify, a light-year is the distance that light can travel in a vacuum in 1 year, a whopping 9.46 trillion kilometers. Now, theoretical astrophysics studies are all well and good, but aren't there also ways and means to approach this profound topic in a more practical way? Well, yes, there are. As you may know, the James Webb Space Telescope has been casting its infrared gaze at the deepest secrets of the universe for 2 years now, and it has reminded us more than once how distorted our understanding of the universe was in the past. The extrasolar water world, as the most powerful space telescope in history, Webb could detect the heat of a bumblebee on the Moon's surface from Earth. But the telescope, which was specially designed for infrared astronomy, is not particularly interested in chubby insects, preferring instead to give us spectacular images from the depths of space. The James Webb Deep Field or the Pillars of Creation send their regards. Yet, since the start of its scientific mission in the summer of 2022, Webb has also come up with a couple of mysteries. According to this, it has now discovered a whole series of early galaxies that appear to be much too large and massive for their time of origin, a few 100 million years after the Big Bang, and thus stand in stark contradiction to current cosmology. In addition, the data collected by Webb should also deepen our understanding of the mystery of the so-called Hubble tension, and we don't know why the universe is expanding faster today than our theories allow. What we do know, however, is that there is an exoplanet out there called K218b that is quite something, and that can be taken quite literally. Located in the constellation Leo, almost 125 light-years from Earth, this planet is suspected of harboring a fully developed ocean world. However, these so-called Hycean planets also have a small but crucial catch: so far, they only exist on paper. What is described in theory as a habitable exoplanet covered in water is still awaiting official confirmation in practice. Yet, the data collected so far at least suggests the compelling conclusion that it could indeed be a wet and happy place on K218b. That's because the Hubble, Kepler, and Spitzer space telescopes collected data even before the start of the Webb era, and that data literally screams that the planet's atmosphere contains water vapor. It is common knowledge that the existence of water in a permanently liquid form is a fundamental prerequisite for the emergence of life similar to that on Earth. Since K218b lies in the habitable zone of its home system, the framework for this basic requirement is definitely in place. Accordingly, the exoplanet orbits its host star, the cool dwarf star K28, at a distance that allows for the presence of liquid water. In detail, the distance between the two celestial bodies is only about 0.14 astronomical units, which means that K218b takes just 33 days to orbit its star. However, since the star in question emits significantly less energy and heat than our Sun, K218b receives almost the same amount of radiation as the Earth. In terms of mass, however, the differences are all the greater. The exoplanet has 7 to 10 times the mass of our earthly home and is also classified as a super-Earth. But before we misunderstand each other, it should be noted that this term refers only to the mass and not to the habitability of an extrasolar rocky planet. Is there extraterrestrial life on K218b? We have known of the existence of K218b since 2015, but that its atmosphere contains dimethyl sulfide, or DMS for short, is something we have only known for a few months. To understand why this discovery could be so groundbreaking, let's revisit what we mentioned at the beginning. On Earth, DMS is typically produced by living things, mainly by microorganisms such as phytoplankton. Furthermore, DMS is the main source of atmospheric sulfur, and it acts as a cloud seed and provides the typical oceanic scent. The fact that the Webb data collected with the NIR-SPEC near-infrared spectrometer included the spectral signatures of methane and carbon dioxide, as well as those of DMS, was described by the lead researchers from the University of California, Riverside, as the proverbial cherry on the cake. Because if astronomers have really succeeded in detecting DMS on K218b, this could provide a strong indication of the existence of extraterrestrial life. But how is it that, despite all this, scientists are still exercising cautious restraint? Well, the fact that the existence of our extraterrestrial neighbors has not yet been officially announced is primarily because the captured DMS signal was not particularly strong. Furthermore, it only revealed itself when the experts evaluated the Webb data in a very specific way. In order to put the aforementioned data sets to the test again, the experts therefore decided to reconstruct the water planet and its possible biochemistry using several models. In these, they simulated the suspected planet-spanning ocean and atmosphere and then looked at how much DMS the organisms there would have to produce in order for it to accumulate in the natural gas envelope. At the same time, the researchers tested how quickly the DMS is broken down again due to radiation, and in which atmospheric regions it can be expected. The exciting result of this research study was that biogenic sulfur gases can actually accumulate to detectable concentrations on such hydrogen-rich planets. However, this would only be possible if the organisms of K218b are significantly more industrious than their terrestrial counterparts, because they would have to produce an amount of DMS that is 20 times higher than on Earth. The reason for this is quite simple. A large proportion of DMS is broken down again immediately under the mere influence of IR radiation through photochemical decomposition. However, if the concentrations are higher, which would not be unusual for an ocean planet, the degradation products of DMS have a protective effect. The corresponding molecules, such as dimethyl disulfide or methanol, act as a kind of shield for the lower atmospheric layers and prevent further degradation of DMS. But isn't it possible, aside from such theoretical models, to get a more direct sense of the actual DMS occurrence of K218b? Well, yes, fortunately it is, but not with Webb's NIR-SPEC. This is because the DMS signal captured by NIR-SPEC appeared in a spectral line at a wavelength of 3.4 micrometers, which overlapped with the methane signal. In order to more clearly separate the two molecular values from each other, the researchers will therefore rely on Webb's MIRI spectrometer in the future. This works in the mid-infrared range, and thus precisely in the range in which the DMS and its companion products leave their traces. Unless something unforeseen happens, the scientists want to get to the bottom of the secret of K218b life before the end of this year. So, we may know in the foreseeable future what the atmospheric signatures of this distant world are really all about, and with that, possibly, that we are not alone in the universe. And now, you can leave your signatures under our video and show us that we are not alone in the YouTube universe. Please hit that thumbs up and subscribe to never miss another video from us again. We'll see you soon.